Good day, ladies and gentlemen. This is Sarah van Grinnen, aka Mr. VG, and what a wonderful chapter to be in. I love statistics because statistics, ladies and gents, is the one chapter that every one of us uses every day. Whether you go to work and you ask yourself, how long does it take me to get to work? That's average. Okay, there's a lot of other applications, like how many loaves of bread do you buy per month? You don't just randomly go and pick like, I need 50 loaves of bread and let's see whether it works. No, averages. And in business, we need averages every day, averages, standard deviations, and all of those beautiful things. But for this video, we are going to look at the lines of best fit. So I want to go and have a look at the previous video's scatter plot. In the previous video, we drew the scatter plot and we just interpreted it. In other words, we kind of guessed and we kind of looked and said, but how does this actually look? How does the line of best actually look? We guessed that the line of best fit would look like that. But for me to get that line, hopefully you can see it's a straight line. Except maybe for that little point there. That's a bit of a dodgy point. Remember, we call them the outlier. Okay? So when we look at that, I am going to start by looking at a straight line fit. Please understand, ladies and gents, that in real life, it's not always going to be a straight line. You can have many different kinds of graphs that could be fitted. Let's say you've got a bunch of points that look like this. That kind of looks like a parabola. Also, you could get lines that look like that. And those lines, I hope you see those little green dots that I did there. Making them a bit darker now. It looks like an exponential graph. But for matric work, we are specifically going to look only at straight lines because those ones I know how to calculate the equation of. So when I start with a straight line, I know that I've got to do y equal mx plus c. But instead of using y equal mx plus c, we are going to use y equal to a plus bx. What does a represent? That's now a good question. Okay? A would represent, if I had to extend this line very badly there, your A value, my apologies, would be your y-intercept. What would be the B value? Well, that would be the slope of this line. So A would be the y-intercept and B will be the slope. The beautiful thing is now you can go to your calculator, put it in stats mode, and literally just put in your x's and your y's and get that specific equation. Now this specific equation is 393,75 minus 41,67x. Now I rounded this off to 2 decimal places purely for the video. In the exam, you've got to be careful because this is one place where they can tell you go to 3 or 4 or even 5 decimals. So please, please, please be careful. Let's now go and have a look, ladies and gentlemen, at the actual plot. Now I went and I drew the actual plot and I got the regression line. And you see It's exactly the same formula as we had earlier. But it's a lot flatter than we thought. Now the question is, but why? But why is it a lot flatter? Let me explain this by looking at what happens if we ignore the outlier. Look at that. It's a lot steeper than the previous one. So here's the question. What does the outlier actually do? The outlier, ladies and gents, the best way for me to explain it is if you take a little, like a rubber band, and you tie it here at the closest point, if you look at that outlier. So the closest point I can kind of see is at that 4. If I put a rubber band there and I pull it towards my outlier, what does it do to my blue line? It pulls it towards being that red line. So in this case, we are creating this tension between when it is not there versus when it is there. So an outlier, when you introduce an outlier, ladies and gents, literally imagine in your mind taking a rubber band, attaching it to the equation and pulling it towards the outlier. And that's what's going to happen to your straight line. Now the opposite is also true. If I release this tension, then the line jumps back to being flat. So it's literally releasing a rubber band and it bounces down. And then it's much cheaper, or much steeper. Not cheaper, but much steeper. Ladies and gents, I hope you enjoyed this video and I hope this rubber band thing makes sense. In my mind, that's the best way of thinking about an outlier. It creates tension between what it should be and what it really is then. And therefore, it creates this rubber band effect. This is Mr. VG signing out. Have an absolutely gorgeous day, a wonderful evening, and a beautiful weekend if it's weekend by you. Tune in to our next video where we are going to now go and predict using our lines of best fit. Keep well. Cheers.